Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. Okay, now we move to the chapter 3, which is Bjt DC analysis. Right. Okay, I will show you the procedure or step by step how to perform the DC analysis for the Bjt transistor with voltage divider bias. Okay, we move to the question. Figure Q3b show bipolar junction transistor Bjt amplifier circuit using NPN transistor. Perform DC analysis to determine the following. Okay, number 1, base current IB, collector current IC, collector emitter voltage VCE, base voltage VB, collector voltage VC, and emitter voltage VE. Given beta equal to 100 and VBE equal to 0.7 volt. Alright. Okay, few steps you need to remember before you perform the analysis for this NPN transistor. Okay, the first step you remove all the AC voltage. How do we remove the AC voltage? Okay, you need to open circuit the capacitors. Alright, so you disconnect all the capacitor, right, to eliminate or to remove the AC voltage, which is from the Vs and V out. Alright, so all individual capacitor you must open circuit. Alright. Okay, step number 2. Alright, you need to split between input which is base to emitter and the output between collector and emitter, right, before you proceed with the analysis. Right, so for the input, normally we require to find the base current. Okay, from the base current we able to find the collector current using formula IC equal to beta IB. Alright, and then for the output, normally we find the VCE, okay, collector emitter voltage, collector voltage VC, emitter voltage, and so on. Right, so you split or separate circuit into two. Okay, number 1 is a input. Okay, input is between base emitter, and number 2 output, okay, between collector and emitter. Right, then the last step you need to perform DC analysis by applying Kirchhoff voltage law, right, to find the voltage. Right, okay, we move to one by one. Okay, we move to the first step, which is remove all the AC voltage by open circuit the capacitors. Right, so you need to redraw the circuit. Okay, we remove the capacitor by open circuit. Right, so you need to open circuit all the capacitor. Right, so your equivalent circuit will be like this. Okay, so this one is your base, collector, emitter. Right, so this one is a RC, okay, RE, R1 and R2, and this one is plus minus VCC. Right, so this one is a the circuit after you open circuit the capacitors. Right, so we apply only DC voltage. Right, so we move to the step number 2. Okay, we need to separate circuit input and output. Okay, input base emitter, output between collector emitter. So the circuit will be like this. R2, R1, this one your transistor. Right, okay, this one for the input circuit, right, from the base and emitter. Right, so okay, this one for the voltage divider. Okay, for voltage divider bias, you need to convert the circuit into Thevenin equivalent circuit. Okay, you need to convert this circuit into Thevenin equivalent circuit. Right, so the circuit will be like this. Okay, plus minus, this one is a VTH, this one is RTH. Right, okay, this one is plus minus VBE. Okay, voltage drop at the base emitter from the transistor. Right, this one is a RE. Right, okay, so we know that for the Thevenin resistor, okay, is equal to RTH equal to R1 parallel R2. Then VTH basically is equal to this one. You apply the voltage divider rule. So basically VTH here. Right, so VTH equal to R2 over R1 plus R2 times VCC. Right, okay, so you can solve this one. Okay, so RTH R1 R2 over R1 plus R2. So substitute the value. R1 is 100k times with 33k over 100k plus 33k. So here you will get 24.81 kilo ohm. Right, then for the VTH, okay, R2, okay, R2 here, okay, R2 is from the question, R2 is 33k. 33k divided by 100k plus 33k times with the VCC. So VCC in our case is 15 volt. So you solve this one, okay, you will get the VTH equal to 3.72 volt. Right, so here we already find the value for the RTH and VTH. Right, so now, okay, you need to go for the step number 3, which is you need to perform the DC analysis. You need to apply the KVL at the input side. Right, so I make a loop here, right, clockwise. Okay, starting from the VTH. Right, so this here, okay, I put here just this one is a V1 and here is a VE. Right, so you need to find the total voltage, because KVL mentioned that the total voltage in one loop is equal to 0 volt, right? So you kena cari, you need to find all the voltage drop, okay, starting from the VTH. Okay, we meet the negative first, so negative VTH, then dia akan jumpa next voltage drop at the intervening resistor. So this one is represent as a V1 lah. Okay, plus V1, or sometimes we call it as a VB. Okay, just put a V1. Okay, followed by voltage drop at the transistor is a VBE. Okay, plus VBE. Then lastly, voltage drop at the emitter resistor, which is VE, equal to 0. Alright. So VTH, okay, you already get the value. Okay, 3.72, or okay, the value I put the value okay, for the last one. Right, so now we need to expand the formula. Okay, so V1 is a voltage drop at the thevenin resistor. So V1 basically here is a current IB lah, right? The current here is IB. So IB RTH, right, for the V1, okay, plus VBE, okay, VBE we move to the other side, then plus VE is from the Ohm law, VE equal to IE RE, right, equal to VTH minus VBE, right? Okay, so now we know that, okay, IE basically is equal to, IE equal to beta plus 1 IB. So you substitute this equation into these equations, right? Okay, substitute this one into the IE lah, right? So you will get here IB RTH plus beta plus 1 RE, okay, equal to VTH minus VBE, right? So you will get here IB is equal to VTH minus VBE over beta plus 1 RE, right? Okay. Okay, now you substitute the value. Okay, so VTH, okay, 3.72, VBE is a 0.7 from the question. Beta, okay, beta from the question is 100, right? So 100, okay, 100 plus 1, 101 times with the RE. So RE is 1.5 kilo ohm, right? So here you will get 17.13 microampere. Right? So you already get the value for the IB. So once you obtain the value for the IB, okay, you may find the value for the IC from the equation IC equal to beta IB, right? So beta in the question given 100, right? So IB, okay, 17.13 microampere. So you solve this one, you will get the IC is equal to 1.713 milliampere, right? So this one is number 2, okay. Number 1 IB, okay, number 1 IB, number 2 IC. Okay, next is collector emitter voltage. Okay, for the collector emitter voltage, okay, from step number 2 just now, okay, I mentioned this one for the input. Okay, to find the output, you must split the circuit into the output. For the output, only the output circuit. Alright, so we only consider collector and emitter. Right, so you redraw the circuit, right? Okay, this one is not necessary, right? It's depend on you lah. Kalau you nak buat, you boleh buat. Kalau you tak buat, okay, you can straight away analyze from the circuit pun boleh. It's depend, right? So base, collector, emitter, right? For me, better you buat lah, because okay, maybe you ada markah, maybe ada markah for this. Okay, plus minus, here is VCC, here is a RC. This one, the voltage drop at the transistor, here we call it as a V collector emitter, VCE, right? Okay, plus minus VCE. Then here is a RE, right? Again, step number 3, you need to apply the KVL. Okay, KVL mentioned that the total voltage in the loop is equal to 0 volt. Alright. Okay, so you buat the loop. Alright, this one counterclockwise. Okay, starting from here. So you can jumpa dengan negative VCC first. So negative VCC, and then follow by this one I put as a VRC. Okay. Okay, plus VRC. Okay, voltage drop for the collector resistor, right? Then plus voltage drop at the transistor, which is VCE, collector emitter voltage. Then lastly, voltage drop at the emitter resistor, plus VE equal to 0, right? Okay, so we see already given in the question, which is a 15 volt. Okay, VRC kita tak tahu. Okay, VCE also we do not know. VE also we do not know. Right. So, okay. So you here you rearrange the formula. VCE equal to VCC minus VRC. Okay, minus VE. Right. Okay, so you expand the formula for the VRC and VE. Okay, you will get VCC minus ICRC minus IE RE, right? Since we know that IC, the value is the value for the IC and IE is very close, right? So we consider IC and IE is a same value, right? So you will get here VCE equal to VCC minus IC RC plus RE, right? Okay, so from the question, okay, VC given is 15 volt minus IC. Okay, just now you get 1.713 milli. RC is 4.7 kilo ohm plus RE is a 1.5 kilo ohm. Right, so you solve these calculations. Okay, you will get the VCE is equal to 4.40 volt. Right. Okay. So next question is okay. So next question is number 4, base voltage VB, collector voltage VC, and emitter voltage. So now we need to find the VB. So base voltage VB basically is equal to, okay, where is your VB? So basically your VB from the circuit, okay, your VB basically dekat sini. This one is your VB. Okay, plus minus, that one is your VB. Right, so how do you find the VB? So VB basically is equal to, okay, VTH minus IB RTH. Right, so okay, substitute the value 3.72 volt, and then for the IB RTH, okay, 17.13 micro, times RTH just now is 24.81k. So here you will get VB is equal to 3.30 volt, right? Okay, so VB is equal to VTH, okay, voltage drop, voltage here, the supply voltage here, minus the voltage drop for the Thevenin resistor, right? So you can apply the value for the VB, right? Okay, this VTH minus IB RTH, voltage drop at the Thevenin resistor, then you will get the value for the VB. Okay, another way to find the VB is from the formula VBE. Okay, or you can use VBE equal to VB minus VE, right? So VB is equal to VBE plus VE, right? So okay, at this step, okay, you need to find the value for the VE first, right? Then you're able to find the value for the VB once you get the value for the VE, right? Okay, so this one later. I hold this one first because we do not find yet the value for the VE, right? So number 5, collector voltage VC. Okay, VC, basically VC is here. Okay, VC. So collector voltage number 5, right? VC. Okay, VC, to find the value for the VC, okay, the VCC must minus to the voltage drop at the RC, then you get the value for the VC. So VC is equal to VCC minus ICRC, right? So VCC is 15 volt minus IC 1.713 milli, RC is 4.7k. Right here you get the value for the VC is 6.96 volt, right? And then number 6, okay, you need to find the value for the VE. Okay, VE. So basically VE at the emitter voltage here, right? So VE basically is equal to IE RE, right? So RE is equal to IC equal to 1.71 milli ampere times with the RE 1.5 kilo ohm. So here you will get the value for the VE is 2.57 volt, right? Or okay, you can use the other formula from VCE equal to VC minus VE, right? So VE is equal to, okay, VC minus VCE, right? We see just now you get the value for VC 6.96 volt minus VE, sorry, minus VCE. VCE 4.40 volt, right? So here you will get 2.56 volt. So the value from this method and this method is almost similar, right? Beza 0.01, right? Okay, once you get the value for the VE, okay, you can find the VB lah. Okay, so VBE, we know that VB is equal to 0.7 volt plus VE 2.57. So here you will get VB is 3.27 volt. Right, so I think from okay, VB from this equation and this equation different only 0.03, right? So tak jauh beza lah, right? So you can use both equations, right? You can choose either one, right? Jangan buat dua-dua, you pilih satu saja. Alright, okay. So that's it for the tutorial on the NPN Bjt DC analysis. Okay, so we move to the next question. Okay, for the PMP. Okay, figure Q3B show Bjt amplifier by using PMP transistor. Perform DC analysis to determine the following: base current IB, collector current IC, emitter collector voltage VEC, base voltage VB, collector voltage VC, emitter voltage VE. So given beta equal to 100, okay, VEB equal to 0.7 volt. Alright, the question is quite similar with the first example, right? But the difference is the first one, they are using the NPN. So the second question, we are using the PMP transistor, right? Right. Okay, for the voltage divider bias, so you must remember that, okay, we need to convert at the input side, we need to convert to Thevenin equivalent circuit. Okay, so the Thevenin equivalent circuit like this. Okay, you have your power supply for the Thevenin voltage, right, plus minus VTH, right, followed by the RTH, okay, Thevenin resistance voltage. Okay, then you have this one is a transistor, right, connect with the RC. So here is a RE, okay, RE. Okay, and then here is a RC. Okay, so here RC, RTH, RE. This one 1.8 kilo ohm. Okay, RE is 120 ohms. Right, so this one connect to the power supply. Okay, plus minus 12 volt. Right, so this one is the equivalent circuit for this one. Right, so we know that for the RTH, okay, so for the voltage divider, okay, we need to apply the RTH, okay, Thevenin equivalent for the resistor. So RTH basically R1 parallel with R2. So RTH equal to R1 parallel with R2. So equal to 39K times 82K divided by 39K plus 82K. Right, this one is a formula for the R1 parallel R2. Say R1 times R2 divide R1 plus R2. Right. So you will get the value for the RTH is 26.43 kilo ohm. Right. Then for the VTH, okay, VTH, okay. So VTH, okay, this one is a VR2, VR2 equal to VTH lah. Okay. So VTH equal to R2 divided by R1 plus R2 times with VCC. Right, this one you apply the voltage divider rule, okay, to get this formula. Right, so now you need to substitute the resistor and VCC with the value given in the question. So R2 is 82K divided by 39K plus 82K times VCC is 12 volt. So here you get the value for the VTH is equal to 8.13 volt. Right, so we already find the value for the RTH and VTH. Alright. So now we need to find the value for the IB IC for the input side. For the input side, we consider at this side. Alright. We need to apply to perform the analysis. We need to apply the KVL. So this one you must remember. Untuk buat analysis, you kena gunakan KVL. Tak nak kena gunakan KVL. So the KVL rules mention that the total voltage in one loop is equal to 0 volt. Alright, so you tengoklah kat sini. You consider at the input side. Alright. So to perform the analysis, you must start from the VCC here. So the direction to be like this lah. We change color. So the flow for your analysis for your KVL to be like this, starting from here, then go to the RE, followed by base, and then next RTH, VTH anti ground lah. So we're starting from here, anti here. So you're starting from the VCC. Starting for the PMP, you're starting from the VCC. So negative VCC, right? And then you will meet the voltage drop at the RE. So this one we call as a VE lah. Plus VE. This one is a VE. And then here we have a positive and negative. Here is a V emitter and base, VEC. Right, so then you meet the VEC. Right, then you can jumpa RTH, voltage drop at the RTH. So this one we represent as a V1 plus V1. Next you can jumpa, you will meet the VTH, so plus VTH. Then lastly you equal to 0. There is no more voltage drop after the VTH. Alright. So next is you need to expand the formula lah, right? So I will split between the we expand the formula and the variable that having the value. For example, the VCC dia ada value dia lah. For example, in this case 12 volt. So kita asingkan dia. So VE is a IE RE, right? We expand plus V1 is a RTH, voltage drop at the RTH, so IB RTH, alright, equal to VCC minus VEC, minus VTH. Alright, so since we know that IE equal to beta plus 1 IB, so you substitute in this the formula in the IE, so you replace it, so we get beta plus 1. Saya terus simplify dia, so we get here IB equal to IB beta plus 1 RE plus RTH equal to VCC minus VEC minus VTH. Right? So you will get the IB equal to VCC minus VEC minus VTH over RTH plus beta plus 1 RE. Alright, so this one is formula for the IB for this circuit. Alright, so now you need to replace voltage and resistor with the value yang diberi dalam soalan. So VCC given is 12 volt minus VEB. So VEB here, VEB. Okay, so not VEC, so VEB. Okay, emitter to base. Okay, not emitter to collector. Okay, so this one is a VEB. Right. So with 12 volt for the VCC minus VEB is 0.7 minus VTH 8.13. Right, divide by RTH 26.43 plus beta just now given in the question is 100, so plus 101 times RE is 820 ohm. Right. Okay, so here you will get around 29.01. I calculate first. Yeah, 20 plus 26.43. Okay, this one is kilo. This one is, I forget to put a kilo here. Right, so 12 minus 7 minus 8.13. So okay, so here you will get 29.002. Okay, 29.02 microampere. Right. Okay, once you get the value for the IB, so number 1. Okay, number 2, you can find the value for the IC. Right, so IC equal to beta IB. Okay, beta 100 times with the 29.02 micro, so you get here 2.902 milliampere. Right. Okay. So now number 3, okay, at the output side. Okay, number 3, okay, at the output side. Okay, you need to find the value for VEC. So at the output side here, alright, we have here plus minus VE emitter to collector VEC. Right, here we have VRC. Right, here we have a VE or VRE. Right. Okay, so we apply the KVL, right? Okay, according to this loop. So starting from the negative 12, so negative VCC, right? So it's a VCC, yeah. Okay, VCC plus VE or VRE. VRE plus VEC plus VRC equal to 0. Okay, KVL total voltage in the one loop is equal to 0 volt. Right, so okay, here we want to find the value for VEC. So VEC equal to VCC minus VRC minus VRE, right? So VRC is equal to ICRC minus VRE is a IERE. Since we know that IC is equal to IE, right? So you get the value, the formula for VEC equal to VCC minus ICRC plus RE, right? So you substitute the value. VCC just now is 12 volt minus IC is IC is 2.9. IC is 2.902. 2.902 milli. RC is 1.8 kilo ohm plus RE is 120 ohm. Right, here you will get value around so you will get around 4.397 volt or 4.4 volt. Alright, okay, now next, we need to find the value for VB, VC and VE. Right, so VB, VB base voltage, so your base voltage here, VB plus minus VB, right? Okay, so VB is equal to VTH minus V1, which is V1 is a voltage drop for the RTH. So VTH minus IB RTH. Alright, so VTH just now is 8.13 volt minus IB is 29.02 micro times with the RTH is 26.43 kilo ohm, right? So you calculate this one, you will get the value around 8.89 volt. Alright, okay, then the next question, you need to find the VC, and lastly you need to find the VE, right? So VC, VC here, VC is equal to VRC equal to ICRC, right? So IC just now is 22.902 milli, right, times RC is 1.8 kilo ohm. So here you will get 5.22 volt. 5.22 volt for the VC. Okay, and finally you need to find the VE. So VE, VE basically at here, which is VE is after voltage drop from the emitter resistor. Here VE, right? So VE basically equal to VCC, voltage here minus the voltage drop at here, then you can get the value for the VE. So VE equal to VCC minus VRE. Alright, so VCC minus VRE is a ICRE equal to VCC just now is 12 volt, IC is 2.902 milli times VRE is 120. Right, so here we get VE equal to So we get here the value for the VE is equal to 9.62 volt. Right? Okay. So okay, for the VE, okay, you can use the other method, okay, using the VEC, right? VEC. So VEC equal to VE minus VC. So VE equal to, okay, VEC plus VC. Okay, VEC is a VEC 4.4. Okay, 4.4 plus VC is 5.22. Okay, we get here 4.4 times plus 5.22. So you will get here 9.62 volt. Right? You will get the same value. Right? Same goes to the VB. Okay, VB. You can use the VEB formula. Okay, VEB equal to VE minus VB. Right? So okay, you want to find the VB. So VB equal to VE minus VEB. Right? So VE, okay, from this formula, from this value, okay, 9.62 minus VEB is 0.7. Right? So 9.62 minus 0.7, so you will get 8.92. So value the value is so close, so sangat dekat. So okay, so we consider the value using this method, this equation, and this equation is almost the same. Alright, okay, that's it for DC analysis. That's it, the DC analysis for the PNP transistor. Right, so hopefully you guys are able to understand. Right, so if let's say you do not understand, so you can ask me in the class. Okay, before we end our video today, so I have some exercise for you. Okay, so basically we have a two question, right? So please spend a little bit time to do this exercise. Right, so I already attached together with the final answer. Alright, so for the number 4 and number 5 to just ignore. Okay, you can do for the first 3. Right, okay, I think that's it for the video about this topic. Right, so see you on the next video. Thanks for watching.